We use products made by chemical engineering every day. The soap you used this morning, the bread you ate, the chips inside your phone. Not this, the actual silicon chips. All of it exists because of chemical engineering. But if someone asks you, what is chemical engineering? You probably wouldn't know. You might think maybe some mixing of colorful liquids. That's a chemist. Chemical engineering is different. Nobody really explains it properly. Even if you ask some engineers, they would be like, yeah, something with chemicals, I guess. But relax, I got you. So, what is chemical engineering? The definition is chemical engineering deals with study of operations and design of chemical plants and methods of improving production. I know you didn't understand it at all. So let's simplify it. Chemical engineering is basically cooking. That's it. I'm not kidding. If you can understand cooking, you can understand chemical engineering. You don't need a 200 IQ for this. Now think about making fries. Yeah, you're in your kitchen, you take potatoes, wash them, peel them, cut them, fry potatoes in oil, add salt and spice, and boom, fries. You just upgraded potatoes into something more valuable. That transformation right there, that's the core idea. Now scale that up. Instead of a kitchen, imagine a massive industrial plant. Instead of potatoes, you're dealing with chemicals. And instead of making one plate of fries, you're making tons of product. The steps are the same. You take the raw material, you clean it, process it, react it, separate what you need, and recycle what you don't. Now let's take making ammonia for example. Ammonia is made from nitrogen and hydrogen. So you have nitrogen and hydrogen gases as your starting ingredients. First you remove the impurities, then you send the gases to a reactor and let the reaction happen to form ammonia at high temperature. Then you take the resultant mixture to a cooling tower. Then you take this cooled mixture to a separator. You remove the unreacted gases and recycle it back to the reactor. Obviously we have to reduce waste and maximize our output. And finally, you're left with ammonia, the desired product. This process is called Haber Process, and this was just a very simple layout of it. But you can see the steps are very similar to what we do in our kitchen. All these individual steps are called unit operations. Now let's circle back to the earlier definition. So we use these operations to design a chemical plant process in which we maximize the production of desired product. Let me know in the comments if this is starting to make sense now. In chemical engineering, you are not learning how to mix chemicals to see what reaction will happen. You're learning how to run entire industries based on known reactions. A chemist is someone experimenting in the kitchen, trying new recipes, figuring out what's good. A chemical engineer is one who takes those recipes and figures out how to serve million people every day with it, without the kitchen exploding or going bankrupt. You're dealing with tons of material, high pressure, high temperature, long operating hours, and things don't behave the way they do in a lab. Sometimes heat doesn't dissipate, mixing isn't uniform, side reactions show up. These are the problems that chemical engineers solve. And there is one ultimate constraint: money. Because companies don't care if the process works if it's expensive. So you're always optimizing for less energy, less waste, lower cost, and more output. And finally, there is also safety. Because you're dealing with explosive materials, toxic chemicals, and extreme conditions. Mistakes aren't cheap. It can be a disaster. But smart as you are, you design everything with backup. There are sensors, pressure relief systems, emergency shutdowns. Everything is built with the assumption that something might go wrong, and there needs to be a way to handle it. Now let's look at the degree itself. It's hard, because it's abstract, and you won't see the application immediately. You'll be solving differential equations and thermodynamics, and you can't see these things in real life. But once things click, your perspective changes. You'll start seeing things differently. A pipeline won't be just a pipe anymore. It's a pressure drop and a flow regime. So finally, what is chemical engineering really about? It's about control. You control reactions, control systems, and control outcomes. And that's why it's everywhere, even when you don't notice it. Now hit that like button so more people can stop thinking it's just mixing chemicals. And if you want more videos that break down chemical engineering concepts, subscribe and stick around.